Welcome to the session of Thermodynamics. In this session, I will discuss what are the basic concepts those are involved in the subject thermodynamics. So at the outset, I want to give you the feel of the subject, that how this thermal interaction is taking place and how the temperature behaves with its surrounding. So I have taken a very interesting example that you can see it on the slide, that at the left side there is a cup of tea and at the right side there is a glass of cold drinks. So I am giving you a situation that both cup of tea and the glass of cold drinks is kept on the table, that it is directly exposed to the atmosphere. So what will happen after some time? There is a very general understanding that everybody can understand, that the tea which was at higher temperature, that has cooled down, and the cold drinks which was at lower temperature, the temperature has got increased. So this is also a thermodynamic process which has occurred naturally. Further in the subject, we will cause such processes to occur purposely in thermodynamics. Now by taking this example, we have understood how the thermal interaction is taking and how the temperature behaves with their surrounding. Now coming to the definition part of the thermodynamics, the word thermodynamics, it originates from the Greek word thermi and dynamics. Thermi, that means heat, and the dynamics, which is related to the force. So we will define the subject as the science of energy transfer and its effect on the property of the system. In thermodynamics, we will mainly deal with the two kinds of energy transfer, that is heat interaction and the work interaction, that we can also call as heat transfer and the work transfer. So try to understand the triad of the thermodynamics, that is heat, work and energy. One thing should be noted, that heat is considered as a disorganized form of energy and the work is considered as a organized form of energy. So the final aim of the thermodynamics is to convert the disorganized form of energy, that is heat, into organized form of energy, that is work. Now we will try to understand some of the basic terms and terminology that we will use in thermodynamics more frequently, and that has got some technical and precise meaning. In the definition, you can see I have marked two words, one is a property and the another is a system. So it has got some technical meaning in the thermodynamics. We will try to understand one by one what is it. So first thing, I have taken system. So in the figure you can see I have marked this oval shape as a system. Why I am calling it as a system? Because I have taken some region in the space on which I am focusing my study, so that I am calling it as a system. So I have defined it. It is a region in a space upon which the study is concentrated or focused something. Now what about the external to the system? This system is separated through a layer that we will see. I am calling it as a boundary, but anything which is external to the system, that is surrounding, and this thin layer which separates this system and surrounding, that is boundary. This boundary is also important. Remember, this boundary can be rigid, it can be movable, or it can also be real or imaginary. If you try to understand the movable boundary, further we will see some processes where gas is expanding or gas is compressing. So there boundary is not limited, boundary can move, but system and surrounding, it is separated through this boundary. Together this system plus surrounding, that constitutes the universe. Now we will see what kind of system is there in the thermodynamics. So these are the types of thermodynamics that you can see here. We have subdivided it into open system, closed system and isolated system. When we will call a system as an open system, the open system is one where mass transfer can take place and energy transfer can also take place. Mass transfer means mass or matter can be added or removed something. For example, you can take the example of pump, compressor or turbine. So here mass transfer is taking place as well as the energy transfer is taking place. Now what kind of system we will call as a closed system? In the closed system we cannot have the mass interaction, means we cannot add mass or we cannot remove the mass. Mass is constant, but energy transfer can take place. There is no chance of mass transfer, but energy transfer can take place. So you can take the example of a closed water bottle. As it is a closed, I am not going to add or remove some water, but if you are going to keep it in the freeze, it can cool down. So means energy transfer is taking place, but mass is neither added nor removed, but energy transfer is taking place. Now what is isolated system? Try to understand with example. Hot coffee in a well insulated flask, it can be considered as a isolated system, because if it is insulated, then there is no heat transfer is taking place, and as there is no mass is added or removed, so there is no mass transfer is taking place and no energy transfer is taking place. Such kind of system we will call as isolated system. So I have marked two words in the definition of the thermodynamics. One was the system, so we have tried to understand what is the system and what kinds of system is there in the thermodynamics. Now coming to the property. In general, property is nothing but the characteristics of a system. So what kind of property is there in the thermodynamics that we are going to deal with? So thermodynamics, the main property or the first property that is coming in the mind is the temperature, because thermal itself, it relates to the temperature, but many properties are there. Temperature, energy is also a property, pressure is there, volume is there, density. But main aim, how we are dividing such kind of property in thermodynamics in extensive and intensive. So we will try to understand what is intensive property. Intensive property I have given in short that it is independent of size or mass. So try to understand this with an example. I have taken purposely the example of a temperature. So this block has a temperature T, and independency of mass or size. It means if I am going to divide this block into different parts, or if I will subdivide this block into 2, 3 and many more parts, as I have taken here 4 parts. So all the parts will have, or all the blocks will have the same temperature T, as earlier it was at temperature T. Now each individual blocks has the same temperature, means it is independent of size or mass. Now we will try to see what is extensive property. The extensive properties are those properties that depends upon the size or mass of a matter. Here I have taken the example of a volume. Suppose this block has a volume V, and if I am going to divide this block into different parts, so I have taken 4 blocks. This block is divided into 4 blocks. So will all the blocks will have the same volume? No. If it is divided, the volume is reduced. So this is dependent on the mass or size of the matter. So such properties which depends upon the mass, we will call it as extensive property. Now coming to the some of the approaches that is more common in thermodynamics, and what approach we are going to deal with in thermodynamics. So mainly there are 2 kinds of approach. One is the microscopic approach, where the individual behavior of the molecule is taken into consideration, and this concept is mainly used at higher altitudes, because their molecules are separated, because these are low density region. So there we cannot take the average behavior, because molecules, if the molecules are separated, we should go for the individual behavior of each molecule. And this approach is also known as statistical thermodynamics. But in this our course, we are going to deal with the macroscopic approach. Here the behavior of individual molecule is not taken into consideration, rather average behavior of the molecule we are going to take into consideration, and this approach is also known as classical thermodynamics.